Hi, I'm doing Paul McWhorter's Arduino R4 lessons, and I'm also doing his PicoW lessons, and I'm finding it an awful lot easier to do the PicoW lessons for several reasons. I never save my program that I'm working on to main on the PicoW if I can help it, as it's much easier to store programs on the PC, and you can do things on the Pico from the shell, which can be quicker than writing a program. So Arduino was a bit of a shock, always having to upload a sketch and not being able to stop it, and also I'm not very good at C++. So I was looking at the examples the other day, as in there, and all the built-in examples, and I was looking down there, and I happened to notice pyfirmata. And I thought, what is pyfirmata? So I did a bit of investigation, and I learned that you can update one of the various pyfirmata sketches according to what you want to your Arduino, and then communicate with it from your PC, for example, or your Mac or whatever, in a variety of languages. So I am using standard pyfirmata because it's the easiest to cope with, I think. I haven't tried the others. And I will be communicating with the Arduino in Python, not MicroPython. So what you do is you go onto pyfirmata, you click that to upload it, but I've already got it, not to upload it, to get it in to your editor, and then you just upload it. I won't do that because it's already there, and it will just sit there and it will wait for someone to communicate with it. And what you need to do is, if you look on tools, port, you need to remember what port you're on. So if you are on Thonny, go on to Thonny and you make sure you're on local Python, not other Python, and you go on to manage packages, and then you search for pyfirmata, search, right, pyfirmata. If you click on that, I've already installed it, but you would need to install it. So I'll close that because it's already there. You can see it's there. Now you've got your pyfirmata installed, and you've got your program sitting running on your Arduino waiting for something to happen. So you just need to write a very simple, to begin with, program, which you just go import pyfirmata, import time. Now then you have to, make an object for it to communicate. So you can just call it board equals pyfirmata dot Arduino. Then you have to tell it which port you're on, like that, and hopefully you, what have I got that there for? I didn't want that. Right, then you can just write a while true loop, true, and then you just go board, and you want to go a digital, this starting off with a blink program, so it's just a digital write. So you go digital number 13, which is the standard one. I've actually got it so it flashes on the board underneath there, and it's the little LED up there. So you put that on, you go time. Oh, no, I haven't written it. That's that pin. Yes, sorry. Then write 1 to turn it on, time dot sleep of 1 will do. Copy those two lines and you just write 0. Now hopefully that ought to do the business. We will just run that program. Oh, right, that I kept the caps lock on. COM4, not $. We'll try that again. Right, it's running. The Arduino's thinking about it, and look, it is flashing the LED on and off, which is great. So that means it's a really easy way of being able to do a digital write. And what do you need to do when you're communicating with your Arduino board? You need to do digital write, analog write, or kind of pseudo analog write, digital read, analog read, and digital read. So we've got that. So if I stop that program, the Python program has stopped, but the Arduino program, the LED is still on because it just happened to catch it when it was on, but the program is still running in the waiting for someone to do something. So what I like about this is you can actually do it in the shell. So if you come down here, I'll make that a bit bigger if I can. Where is it? Come on, draggy thing. There. Oh, look. There, I'll make that a bit bigger. So you can just, in the shell, copy and paste. Then you want to do your board command again. In the shell, copy, paste. And then you don't need a sleep and you don't need a while true. You just take that line, copy, I've forgotten to press enter, paste that, and it won't of course do anything because it's already on, but we will try the next line to see if we can turn it off. Copy and paste. Will it turn off? Yep, it turned off. And you can turn it on, and you can turn it off, and that's great because you don't have to write a program. I know that isn't exactly rocket science, but it is a lot easier. So I will just stop there in case everything goes horribly wrong. So now we've done the digital output, we now want to do digital input, and the easiest way to do that is with a button. So to do this, you first need to find out whether any input is coming in from the Arduino. So in case I forgot what this did, I've given it a very meaningful name here. So keep checking for input equals pyfirmata dot util dot iterator. Is that right? On the board. Whoops, what have I got rid of that? Yeah, keep checking for input equals python. Okay, copy that bit. Dot start, and all that does is it will just keep checking for input. You don't need to worry about anything at all. So that's the first bit. Then we need to add the button. So if I go board dot digital, I think it's 2 dot mode equals pyfirmata dot input. That looks good. Now I just need to change this while loop. I will just go but equals read, like that, and then I just put if but, as in if anything's happened. No, that isn't if anything's happened, that's if I pressed it. That's if it's down. Then I go board digital 13.write, like that. Don't need sleep anymore, but I do need an else here. Else. Turn it off, and I'm going to put in a little sleep there so it isn't pounding the poor old Arduino to death. Now, will that work? I don't know. Probably. We will just see whether that works. Right, something's happening. It's kind of thinking about it, getting in. I've got it the wrong way round. I think I've got it the wrong way round. Well, that's odd. Maybe it is just the other way round. We'll run it again. Right. Try pressing it. Down. On. Yeah. There. That works like magic. Now you can change the syntax of by using board.getPin. So if I change that line, I'll get rid of that. If I change that line to leave it there just in case. It wants to be but equals board.get underscore pin, and then you can say D, oh no, it wants to be in quotes there, in quotes, then it's D for digital, colon, the number of the pin, which is 2, colon, I for input, close the quote, close the bracket, and hopefully that ought to do what it ought to do. And then you can do the same thing with the LED. So I'll copy that line, and so that wants to be LED, board get pin, digital, but it wants to be 13, and it wants to be output. So we don't need that line anymore. And here I think you can just go if but dot read, like that. Get rid of that line, and then you just put can't remember, I need to look at my bit of paper. Then you just change that to LED and LED. Now that looks an awful lot cleaner and nicer, but will it work? Probably made a mistake. Right, hasn't gone wrong yet. We'll try pressing the button. It still works. So that's great. So that is digital write. No, digital read, sorry. I'll stop that there. We've now done digital in and digital out. We'll now try analog in. And the easiest way to do analog in is to use a potentiometer. So the top bit is just exactly the same. I've just declared the potentiometer as analog pin 3, and it's just saying the pot value equals pot read, printed out, and you sleep for a little bit to stop thrashing your poor potentiometer. So we'll run that. When it stopped flashing. Ah, right, there's the value, and if you turn it up, it goes up, 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 up to 1. And a thing to note is using pyfirmata on anything analog, everything's in the value of 0 to 1, which does make life easier. So if you compare, if you're moving a value from 2 to the power of 10, and then you're making output to 2 to the power of 8, doing it like this with just the values of 0 to 1 makes it very simple. Right, so we will stop that because that's fairly boring. Then my next program is you control the blink rate with the potentiometer. So I've got the potentiometer, which is analog in, and then I've got the LED, which is still that one up there. And what I'm doing is I'm using the potentiometer to set the blink rate. So it the delay in between the blinks is anything from 0 to 1 seconds, but you don't really want it to. If it's 0, it could mess up your LED, because I don't think your LED would like coming on and off, on and off, on and off with a delay of 0. I think it might break it. So that's why I'm adding a little bit to the delay, just to stop the LED frazzling. And so we'll just run this. Yeah, we'll run this and see what happens. Right, it's blinking fairly fast. If I turn it to the right, that makes delay as long as it can be, like one second. So it's blinking slowly. So if I turn it that way, decreasing the delay, it's blinking faster. It's blinking faster, blinking, and then when I turn it right over there, that is blinking so fast you can't actually see that it's blinking, but that's what it's doing. So that all seems to be working. I will stop that. Well, if I move that over there, then maybe it will turn off. I press off. Nope, it didn't. Right, that is analog in, digital out. One more to show you. This is control the brightness of a PWM LED with a potentiometer. So I've changed the LED. I'm not using that LED. I'm using that PWM LED. So I'm declaring that it's digital pin 6, and instead of input I for input or O for output, you can put P for PWM. It has to be on a pin that has a squiggly against it, but that one does. So all I'm doing is reading the pot value. If there is a pot value, I'm just writing it out to the LED. So we'll run that. Don't look at that one. It's that one. Right. So that's full brightness, and if I turn it down, down, there. Sorry, that's a bit, don't know what that's doing on there. So you can see, you can control the brightness of the PWM LED with the potentiometer. Stop that and stop the video. I've just got one more thing to show you. Now I just wanted to show that you could actually do something that you wouldn't, well, I wouldn't be able to do on the Arduino by using this. So I'm actually using TK Inter, which I am not very good at TK Inter. So all I'm doing is I'm controlling the brightness of my that LED, my PWM LED with two buttons. So I've got, it will show on the screen, it will show the value of the brightness, and then I can turn it up and turn it down. I mean, you just have to ignore all of that. I'm not very good at TK Inter, so it is all happening in the increase and the decrease. So if we just run this, there, that little window has got the value of the brightness, it's got decrease, increase, and so we'll see what happens. So if we press plus, I'm doing it in tens, so it actually shows. So you can see that that's come on. So if I go up, 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 it's getting brighter, it's getting brighter. I can't really see that it's getting much brighter because it doesn't. And then it goes up to 255, doesn't go any further. And then I'll just take it down to 0. You can vaguely see that it's getting dimmer, 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 yep, dimmer, and then it goes down to 0. So that's just a little thing to show that you can get it working with something like TK Inter. So that is the end. Hope you find it useful.